This simple question you see here is actually a very good one, because it requires knowledge of exactly 4 trigonometric identities. First, let's take a look at which concepts we need to know. First, if two angles add up to 90 degrees, the sine of one is equal to the cosine of the other. The same rule applies to tangent and cotangent as well. If the angles add up to 90 degrees, the tangent of one is equal to the cotangent of the other. If you add the square of sin x and the square of cosine x, it equals 1, and the product of tangent x and cotangent x is also equal to 1. You can find a detailed explanation of these identities on my channel. For this question, I will use these identities. Now let's start solving the question. First of all, I see that these angles here add up to 90 degrees. Here, the first thing that catches my attention is the sine-cosine identity. I say, since the sine of one angle is equal to the cosine of the other when the angles add up to 90 degrees, I can write sin 70 as cosine 20. So I write cosine 20 instead of sin 70 here. Now I'm moving on to the lower part. I'm going to use a similar identity in the lower part as well. Now these also add up to 90 degrees. So I apply the same thing to tangent and cotangent. That is, if the angles add up to 90, the tangent of one is equal to the cotangent of the other. So I can also write tangent 65 as cotangent 25. I write this in its place as well. I've used my first two identities. I have my last two identities left. Now the identity I showed earlier comes to mind for sin squared and cosine squared. In short, the sum here equals 1. I write this in its place. Now the identity below comes up. There, since tangent x times cotangent x equals 1, their product will also be 1, and thus I find the answer to the question as 1.